Have you ever wondered how file processing works in C++? It's a critical process that involves reading from and writing to files. This is made possible by C++ providing an array of classes and functions within the header. Declare an inputFile.stream object, open the file, read data from the file, and finally, close the file when you're done. Now with this basic overview in mind, let's dive into the specifics of how file processing is done in C++. Let's start with how to read data from a file in C++. Diving right in, the first step is to include the fstream header. This is accomplished with a single line of code, #include number. Once we've read all the data we need, it's important to close the file. This is done by calling the close method on our inputFile object, inputFile.close. Closing the file is crucial as it frees up the resources that the operating system allocated to handle the file. Let's quickly recap with a full example. In this program, we open a file, check if it opens successfully, read numbers from it until there are no more to read, and then close the file. If the file fails to open, we print an error message and return an error code. And that's how you read data from a file in C++. Output. Now, let's move on to writing data to a file in C++. This process is just as straightforward as reading from a file, thanks to the robust functionality provided by the fstream header in C++. The first step in writing to a file is including the fstream header in your program. This header provides the necessary classes and functions for file input and output operations. Next, you need to declare an outputFile.stream object. This object is essentially a bridge that connects your program to the file you want to write to. In C++, you can declare an outputFile.stream object using the ofstream class. Once you've declared your outputFile.stream object, the next step is to open the file you want to write to. This is done using the open method of the outputFile.stream object. When you call this method, you pass in the name of the file as a string argument. Now that your file is open, you're ready to start writing data to it. This is done using the insertion operator, which is represented by two less than signs. You can think of the insertion operator as pushing data into the file. On the left of the operator, you have your outputFile.stream object, and on the right, you have the data you want to write. You can write any type of data that can be converted to a string, including numbers, characters, and even custom data types. Once you've written all the data you need to your file, the final step is to close the file. This is done using the close method of the outputFile.stream object. Closing a file when you're done with it is a good practice as it frees up system resources and ensures that all changes to the file are saved. So, to summarize, writing to a file in C++ involves including the fstream header, declaring an outputFile.stream object, opening the file, writing data to the file, and finally closing the file when done. And just like that, you've written data to a file. And that's how you write data to a file in C++. What if you want to add data to an existing file without deleting its current content? You're in luck! C++ provides a straightforward solution. It's called append mode. When you open a file in append mode, any data you write to the file will be added to the end, maintaining the existing content intact. Let's dive into this. To open a file in append mode, you start off just as you would when writing to a file. You include the header and declare an outputFile.stream object. But when you open the file, you'll add a second argument to the open function, std ios app. This tells C++ you want to open the file in append mode. Here's what it looks like in code. std ofstream output file, open, output, txt, std, eoc app. Now, any data you write to the file will be added at the end, after any existing content. You can write data in exactly the same way as when you're not in append mode. After writing, remember to close the file as usual. So, let's sum it up. Appending to a file in C++ allows you to add data to the end of a file without overwriting the current content. This is done by opening the file in append mode, using the std ios app argument. And just like that, that's how you can add data to a file without overwriting its existing content. Working with binary files in C++ involves a few different steps. Let's dive right into it. When dealing with binary files, we use the std ios binary flag. This flag tells our program that we're not dealing with a text file, but a binary one. Binary files can contain any type of data, so this step is crucial. To open a binary file for writing, we use the std ofstream class. We create an object of this class and open the file, passing in the name of the file and the binary flag. Here's how it's done. std, ofstream binary file, data bin std, ios, binary. This line of code opens a file named data bin in binary mode for writing. Reading from a binary file is similar. We use the std, ifstream class, again with the binary flag. Like so, std, ifstream binary input, data bin, std, ios, binary. This opens data bin for reading in binary mode. Remember, when you're done with a file, always close it. This applies to binary files too. It's a good habit to get into, as it can prevent data corruption and other issues. So to recap, when working with binary files in C++, we open the file with the std, ios, binary flag. We use std, ofstream for writing and std, ifstream for reading, and we always close the file when we're done. And that's how you handle binary file I/O in C++. So, we've covered quite a bit about file processing in C++. We've journeyed through the intricacies of reading from and writing to files using the classes and functions provided by the header, declaring an input file stream object, opening the file, reading the data, and of course, closing the file when we're done. We also looked at an example that demonstrated how these steps come together in a practical scenario. Next, we moved on to writing to a file. Here we saw a similar process, but this time we declared an output file stream object. We opened the file, wrote our data, and closed the file. We saw how C++ provides us with the ability to store data persistently, a fundamental aspect of many programming tasks. Just when you thought that was it, we introduced the concept of appending to a file. We learned that if we want to add data to an existing file without wiping the slate clean each time, we can open the file in append mode. This allows us to grow our data organically, keeping what's already there and adding new information at the end. Finally, we dived into the world of binary file I/O. We discovered that for binary file operations, we can use the std, ios, binary flag when opening the file. This opened up the possibility of working with more complex data structures and file formats. These are just the basics, but they provide a solid foundation for more advanced techniques and error handling. Remember, practice is key. So don't hesitate to experiment with these concepts and build your own file processing projects. That concludes our discussion on file processing in C++. Thanks for joining and keep exploring.